Hey there, Mr. Weaver here, and this is Topic 7, Lesson 5, Factoring Polynomials. After this lesson, you need to be able to factor trinomials. You'll know you're successful after this lesson if you can determine the two binomials that were multiplied together to form the given trinomial. We saw this word in the last lesson, factoring. So factoring is the process of rewriting a polynomial as the product of two or more polynomials. Now, in this lesson, we are going to be starting with a trinomial, and your goal is going to be to figure out what two binomials were multiplied together. So here we had 2x squared plus 19x plus 24. We're going to factor it and determine the two things that were multiplied. So in this case, we had the two binomials, 2x plus 3 and x plus 8. In this lesson, we'll go through how to figure out those two binomials. As we are going through, there are going to be two types of trinomials you're going to see. So first one, you're going to see where it's x squared plus bx plus c. That means that the number in front of x squared is 1. These are also called simple trinomials, and the process of finding the two binomial factors is a lot faster and simpler than the next. For these, all you're going to need to do is find the two values that have a product of c and a sum of b. And then you're going to write those values as your factors for your binomials. Our other type that we're going to see is if there is a number other than 1 in front of x squared. Here we have a couple more steps. You're going to start off multiplying a and c. Then you're going to use that number as your product and still b as your sum to figure out your two values. One quick thing, in your book it says product where the word sum is underlined. Please make sure you change that. You are still adding to b. Once you've figured out those two values, you are going to split the middle term into those two values, and we'll show you how to do that. Then you're going to factor out the GCF a few times and regroup things back together. So let's look at some examples of how this works. Here we have a trinomial, and the first thing you're going to need to do is look. In front of x squared, is there a number? So here there is not a number, it's a 1. So once we figure out our values that multiply to c and add to b, then those are the two numbers we're going to use. I'm going to start off writing my two binomials and just leave some space. So because there's a 1 in front of x squared, I know it's just going to be x plus or minus some number times x plus or minus some number. Now we're just going to find two numbers that multiply to 28 and add to 11. So for this and for future problems, I am going to make an x. In the top of the x, I'm going to put what they need to multiply to. At the bottom of the x, I'm going to put what they need to add to. So they multiply to 28, add to 11. I need to figure out those two numbers. Here we have 4 and 7. Sometimes these numbers can be pretty quick and easy to figure out. Here there aren't too many numbers that multiply to 28, but once we start dealing with negatives and larger numbers, it might become a little bit trickier to figure out what the factors are. So let's look at Desmos for a quick trick to figure this out. Here in Desmos, I know that I need my two numbers to multiply to 28. So I'm going to say x and y are my two numbers. I'm going to show they are multiplying to 28. I also know they need to add to 11. As you can see here, we have two different graphs. One's kind of some curves and one's a straight line. If you find where the two things intersect, it's going to give you the two numbers. They'll just be switched. So 4 and 7 and 7 and 4. So those must be my two numbers. Now, because this is a simple trinomial, all I need to do for my final factoring is to plug those two numbers into my parentheses. So my two numbers were positive 4 and positive 7. That means my two binomials that I must have multiplied to get that trinomial that we started with are x plus 4 and x plus 7. To double check our answers, if we multiply what we get back out, you should get the trinomial that we started with. So if I did x plus 4 times x plus 7, I do end up with x squared plus 11x plus 28. So that can be how we can check to see if we are correct. Now it's your turn. Pause the video, factor this trinomial. Use the x and see if you can figure out the two values that were multiplied to get this trinomial. Let's check. You should have found x plus 1 and x plus 9. If we look at our x, 9 would go on top, 10 on the bottom. 1 and 9 multiply to 9 and add to 10. Therefore, those are the two values that we would plug in. Let's look at another example. Again, notice there's no number out front, so this is a simple trinomial that we're going to factor. I'm going to start with my shell of my binomials, finding the two numbers that multiply to 15, add to negative 8. 15 would go on top, negative 8 would go on the bottom. Again, I can find my two numbers using Desmos, so negative 5 and negative 3. If I hop back over to Desmos, they multiplied to 15, they added to negative 8. This time they're connecting down here. My two numbers are negative 5 and negative 3. So that's how we got negative 5 and negative 3. Then, again, I just take those two values and plug them into my binomials. So they would be x minus 5 and x minus 3. Again, if we were to multiply that back out, we should get the trinomial that we started with. Now it's your turn again. Pause the video. See if you can figure out the two binomials after factoring this trinomial. Let's check. You should have found x plus 4 and x plus 5. 4 and 5 would multiply to 20 and add to 9. Let's look at the next example. This time, notice out in front of x squared, it is not a 1 anymore. It has a number there. So, to do this, the first thing we're going to need to do is multiply a and c. So 2 times negative 21, and we get negative 42. That is the number that we're going to need to multiply to. So when we're figuring out the two values, we need to find the two numbers that multiply to that negative 42, but still add to that middle value, which here is a hidden 1. So I'm going to use my x, multiply to negative 42, add to 1. I can head on over to Desmos and figure out the two numbers that multiply to negative 42, but add to 1. We would come up with negative 6 and positive 7. Now, this time, because that number out front is not a 1, we have to do a little bit of extra work. And the way I'm going to show you, you can do it even with the other examples, just you don't have to with the other examples. So for this, we are going to use an area model and go backward. So in the last lesson, we learned multiplying two binomials to fill in the inside. Here, we already know what the inside is. We're going to figure out what the two outside side lengths are that we multiplied. So plugging in numbers, they have to go in certain spots. So the first term has to go in the top left. So I'm going to put my 2x squared there. The last term, minus 21, goes in the bottom right. Always set it up this way. The other two boxes are going to be filled with the values that you just found. So negative 6 and positive 7. But when you fill them in, add an x or whatever variable you have to the end. So those were really minus 6x and plus 7x. because they need to combine together to get 1x. Once you've filled in your boxes, then we're going to find the greatest common factor, our GCF of every row and every column. So you're going to have to do it 4 times. The good thing is there are patterns in what gets pulled out each time. You'll start to see and recognize what's going to come out of each row and each column. Let's start with our rows and work our way with our GCF to the left. If I look at that top row, we have 2x squared plus 7x. The only thing they have in common is an x. That must be our greatest common factor. If I look at the bottom, this time they don't have an x, so I wouldn't be able to take that out, but I can see that 6 and 21 are both divisible by 3. And then don't forget, because that first term is negative, I'm also going to take out a negative. So the greatest common factor for the bottom would be -3. Now I'm going to do the same thing for each column going up. So 2x squared and minus 6x. I can see that both numbers are divisible by 2, and there is an x that I can take from each. So the GCF of those two must be 2x. If I look at the second column, I can take a 7 from both, but not an x. So the GCF there is +7. If you did this correctly, you should be able to multiply it back out and get what's in each box, so you can always use that to double check to make sure you did stuff correctly. Once you've done that, you're just going to take what was on the side and what was on the top, write them as 2 binomials, stick them together. So I had x minus 3 and 2x plus 7. Now it's your turn. Pause the video and see if you can factor 3x squared minus x minus 10. Let's check. You should have found x minus 2, and here's how we get that. So first, to find our values, they would need to multiply to -30. Remember, we'd have to do 3 times -10. And they have to add to -1. Those values we can find using Desmos, -6 and 5. Plugging them into the boxes where they go, factoring out the GCF, we end up with x minus 2. And one thing, it doesn't matter for the -6x and the +5 where you put them, meaning if you had the boxes switched, that's fine. You might end up with x minus 2 on the top and 3x minus 5 on the side. It's the same answer. You have one factor as x minus 2 and one as... Let's look at one last example. Here we have some larger numbers. 20x squared plus 34x plus 6. Sometimes when you're factoring, it's easier if you factor out a GCF first before you factor into 2 binomials. So here, I have a 20, meaning I would have to go through those couple extra steps. But I also notice that 20, 34, and 6 have a GCF. If you can take that out first, please do that. It makes your numbers smaller, easier to figure out. So 20, 34, and 6 all have a 2 in common. So if I pull that 2 out, now I'm left with 10x squared plus 17x plus 3. Now, after I've done that, what I'm going to do is factor the trinomial inside. So I would multiply 10 and 3 and get 30. Then find the two numbers that multiply to 30 but add to 17. So I'm going to use my x, multiply to 30, add to 17. Those numbers must be 2 and 15. Let's plug them in our box. So 10x squared would go in the top left, +3 in the bottom right, and then 2 and 15x. Now I'm going to find the GCF of each row and each column. So doing my rows first, top would be 5x. The bottom, there's nothing in common. 2 and 3 don't have any factors in common. X is not in both of them. That means that the GCF is just 1. Going up, 10x squared and 2x have a common factor of 2x. 15x and 3 have a common factor of 3. Now I have the things on the top and the side. Let's put them together. There are my two factors. One caution, and don't forget, we took out a 2 to begin with, and we just factored what was inside. That 2 still needs to be there, so we can just add it to the front. Now it's your turn one last time. Pause the video. Factor 40x squared plus 53x plus 6. If you can take a GCF out at first, do that. If not, go through, find our values, and factor it out. Let's check. You should have got 5x plus 6 times 8x plus 1. There was not a GCF in this one that you could factor out. First, 40 times 6 is 240, so they would need to multiply to 240 and then add to 53. Then we would find our values of 48 and 5. Again, using Desmos, it can help us solve that quickly. Plugging in our values and factoring out the GCF, we end up with one of the sides is 5x plus 6, the other side is 8x plus 1. In this lesson, we learned about factoring trinomials, which is essentially undoing the multiplication of two binomials, and we are figuring out what was multiplied together to get that trinomial we started with. Each of the examples we saw was a trinomial that ended up with two binomials, and solving them involves the same steps and patterns each time. So first, you're going to want to look, is there a number out in front of x squared? So does a equal 1, or is it something else? If a equals 1, it's a simple trinomial. You can just take the two values that multiply to c but add to b and use those as your numbers in your binomials. When a is not equal to 1, it gets a little bit more complicated, where you multiply a and c, then figure out the values that multiply to that, but still add to b. If the trinomial is more complex, after you figure out your two values, you're going to plug them into boxes for the area model and essentially undo the multiplication by taking the GCF of each row and each column. Once you do that, the resulting values on the side and the top are the factors, your two binomials that you used to multiply and get that trinomial. So essentially, factoring is undoing the multiplication of two binomials. So after this lesson, do you now know how to determine which two binomials were multiplied or are the factors in order to create that given trinomial? So can you go backward and undo that multiplication? If you're not sure about these, go back and look at the first two examples for some simple trinomials or the last two examples for more complex trinomials. This is an important skill that you're going to need for the next lesson and in upcoming chapters. So if you're not sure about these, definitely go back and look at examples to deepen your understanding. And that's the end of lesson 5 on factoring polynomials.